Hey guys, welcome back. This is a newer video. You can probably tell I sound a lot older in this video than in the last one. That's okay. Time flies. All right, problem 3. Now we're not going to solve them anymore like we did before. Now we're just going to see, I wonder what kind of solutions they're going to have. This could be helpful when trying to diagnose a certain graph, or in like physics, a lot of times we say like, did it even reach a certain height, something like that. So let's go ahead and take a look at the discriminant. So the discriminant, like we said in the last video, is just b squared minus 4ac. It's just the inside stuff of the square root. If we get, let's see what we get on this one. So step 1, set it equal to 0. Yay, this one's set equal to 0. How nice. So all we have to do is, well, here, a, b, and c, right? So we're going to do b squared, please use parentheses, minus 4 times a times c. We're not like solving anything. We're just checking out what the value of the discriminant is. All right, so we know that's actually going to be 9. But I mean, you can do this by hand. You can just use your calculator. Hopefully by now you know your order of operations. So see how I got 49 there? See how 49 is positive? Since it's positive, let's see what that means. So it's greater than 0, so it's going to have 2 real roots. 2 real solutions, 2 real roots, however you want to say. It's going to cross twice. What the graph could look like? Well, that particular graph is going to be upside down because of the negative in the front, and it's going to cross in 2 places. It could look like that. It could look like that. It doesn't really matter. As long as it crosses twice, that's what your parabola is going to look like. It's going to cross 2 times. All right, let's take a look. And I could have that picture a little wrong. All I know is that it's upside down and crosses twice. So I could have the parabola in the wrong spot. But it doesn't matter as long as you understand that means it crosses twice. Hey, look, it's already set equal to 0 for us. Isn't that nice? I must want to move things along. So if I do b squared minus 4 times a times c, let's see what we get this time. I get negative 47. Okay, so that's my discriminant. I could write a capital D equals. See how it's negative? Well, negative means that there's no real. There's 2 complex roots. So I'm going to write no real solutions on this one because it's negative. So what would the graph look like? Well, it could look like this. It could look like this. Could look like this. Could look like this. Could look like this. The graph is not going to cross the x-axis. It has no real x values for where y will be 0. You'll learn in 4.8 about imaginaries. It'll be a good time. Oh, now this one is not set equal to 0. That's a bummer. I'm going to minus 20x and put it on the correct side. So I get a big old 0 over here. Put this stuff in order. 4x squared minus 20x plus 25. A, b, and c. So b squared minus 4 times a times c. Let's get that plugged in there. Minus 4 times a. It is my understanding, just so you know, all of you at home, you can watch me type in a calculator all day long, but until you practice it as well, you have a much better chance of success if you're also doing this with me instead of just watching. So I got 0. Okay, so that's my discriminant. It's not positive like the first one. It's not negative like the second one. It's 0. So a discriminant equaling 0 tells me it has one real solution. So I did one of each for you. So you might be like, oh, I'm so excited. I wonder what the graph is going to look like. Well, that means it's going to touch in one spot. Maybe it touches there. Or maybe it touches here. Or maybe it touches there. It doesn't matter. It's only going to touch once or cross through the x-axis once. That's what it means to have a discriminant of 0.